All right, good evening, hams of all license class and all interest level. I see we have another nice group here on our repeater fanciers. So we're going to go into lesson 5. The topic today is what can go wrong in a repeater operation, and then diagnostic actions that you can take with simple equipment to try to cope with those difficulties. This is what a control operator goes through routinely. Well, not routinely, it depends on your repeater. And also, in addition to simple equipment, we'll also talk about some actions you can do with a service monitor. Session should be about 30 minutes long, and then afterwards we can have a question and answer. And the videos are posted on YouTube under my channel, which is K6KN space Bill. And the slides, PDF video links will be posted at barkradio.org. And by way of introduction, I'm Bill Ragsdale, K6KN. I've been an active ham since 2005, but I was a ham as a youth when I was 15 years old also. And I've got a double E degree from Berkeley, and I didn't do much radio until 2005, and then I was active in Boy Scouts, and that got me back into it again. So the sessions we've had so far is the first one was the operating and managing a repeater. The second one then are the components and what they do. The third one then was test equipment and testing the elements of how do you test the components. And then last week, lesson 4 was using a service monitor for advanced testing. And it was, I believe it was quite overwhelming in the content. You really need to see the video again and then go back and look at the slides. And today we're going to be doing repeater diagnostics. And then look for your email, because I'll have a sign up for people to be able to do hands-on training at a repeater setup here at my home. So think of any questions that you have on what could go wrong with a repeater. What kind of problems could you encounter? And this is going to be, for the next little bit, an open mic. So we're going to go back to the attendees. And so please give me some of your ideas on the things that can go wrong with a repeater.
I got, this is Jamie, KN6PWW.
Yes.
Fixed it just a couple of days ago. Power outage, and discovered that the power connection to our battery backup was bad. So plugged everything back in, everything came up, but there you go. And then also discovered that whoever had whatever previous maintenance had been done, for some reason the battery backup wire, the actual cable, was completely missing from our 440 repeater. So there you go, power. Just power.
That's a good one. That's a good one. We'll come up with some answers on that. How about another? What can go wrong? Don't be shy. It'll be quiet.
Interference from an unknown source.
Good. All right, interference. Another one.
How about a stuck transmitter?
Say that again.
Stuck, like a transmitter stuck on.
Stuck transmitter. All right, and any more?
How about critters getting into your equipment and
Critters
dealing with that?
We did have a mouse build a nest in our packet stations some while ago. Very good. All right, that's a good selection to start with, and we'll go back now to screen share. All right, here is a list that I anticipated for common problems, and these are the ones where I have prepared presentations for, and the other ones we can talk about. The first one, of course, is no response at all, a dead repeater. Your users key their transmitter and nothing happens. Another one would be distant repeaters complain that they don't have access anymore. They said, well, I used to be able to work that repeater and I can't anymore, which essentially is receive sensitivity. The repeater can't hear them. Then you have a situation where some users can't hear the repeater. They key it up and other people can hear them, but they can't hear the repeater. And in that case, it's transmitter problems, antennas or power. Another one that occurs in some sites, I've heard it, not very common, but is what I would call repeat ka-chunking. You hear a ka-chunk, 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 ka-chunk. Another one is, which we just experienced, was wind and weather related problems. Another one is distorted audio. And then some comments about after a lightning storm, what could happen. So a few precautions to take before you have a problem. And that is to do a remote repeater sensitivity measurement. If you take a handy-talkie, connect it through a wide-ranging attenuator up to an antenna, say rooftop, and then you transmit and try to figure the dB attenuation that will barely trip the repeater, that will just open squelch, and log that. Because later on, if there's a complaint on your performance, you can make a quick test from your home without visiting the repeater. So if you have that logged, get a complaint, at least you know you have a starting point. So here are several methods that are the generic methods for troubleshooting any system. And the first way is that you start at one end and you work toward the other. If you were doing a communication network, you would start at one end of the field. And if you went through multiple links, you'd work your way from link to link to link, finding someplace in the middle where correct operation stops. And that's your fault point. The second one I call divide and conquer. And this would be done in a large complex system, not so much as a repeater, which is all in one installation. But if you had several units together, imagine you had repeaters that were linked together. In that case, then you start in the middle, make a test, and you check signals one way and the other way, left and right, and you evaluate, is the problem to the left or the right, and then go in that direction and then go to the middle of that path. So you're dividing the system in half. Every time you make a test, you have eliminated half of the area for problems. And then there's the last one, which is one of my favorites, that I call the method of random scratching and clawing. And that is, you just jump in at some point you understand, and you just see what you observe and then try to take it from that point. So as we talked about in lesson number 2, here are the tools that are, excuse me, that are essential. First is a power meter and a dummy load. So you can put this in place of your antenna. This way, when you do testing, you're not live over the air. And then by all means, a transceiver, which has multiple uses, and the RF attenuator we just mentioned. Another one is essential to have a handheld antenna analyzer with a graphic display, not the type that just has meters on the front, but you need the beautiful one that has a graphic display. This way it will give you measurements over a range of frequency very quickly. And you need a voltmeter, a digital voltmeter, all the ones these days. My favorite is Harbor Freight. They're about $16. And then I make up a set of pigtails that match the connectors that we use. And then possibly a service monitor. And as I suggest at the very end, you should know somebody who has one, either own one or share one or know somebody that has one, because occasionally, maybe every year, 2 or 3, you'll have a need for a service monitor. So let's take the case of no response. Repeater, you key up and the repeater does not respond, you have nothing. So in this case, we do the start in the middle and we work left and right. The possibilities could be starting right at the repeater itself. Is the power is bad, and that was one you mentioned just a moment ago, and we'll see how to cope with that. Another is repeater internal failure. That is, the repeater itself is just non-functional. The somewhat more subtle ones, though, is that what I call the output chain. The output chain is the filter, lightning protection, feed lines, antenna, all the stuff on the transmit side could have a problem, or the input chain could have a problem on the receive side, or you could have simply a connector or a cable problem. So the first thing to do is do a quick test with the handy-talkie. You just hit the repeater site and you hit the HT on and make sure you still have a problem. Because I once went to a repeater site that had a significant difficulty, and when we got there, we could not duplicate the problem. It had self-cured, so which was even more of an irritation. The next step up is to verify the DC values into the repeater, and they should be somewhere well above 12 volts, and 13.5 or 13.8 volts is a typical. And in this situation, then after you check the power is okay, then you put a power meter in line to the cavity. That way you can see directly what's leaving the repeater. You key your handy-talkie, and then if there is no response, you are suspicious now of the receive antenna. So in this case, I just take the repeater receiver cable off and stick a 1-inch piece of wire into that antenna socket and key the handy-talkie again. You've eliminated all of the receive side antennas, and a handy-talkie will definitely trip a repeater that close with a 1-inch antenna. And so if you now have a signal, then you check the receive side supply chain, input chain. If you do get a response in that case, then you know that the repeater is receiving input. So now you check the power meter and you check your output chain, and you'll be troubleshooting on the transmit side. And we'll cover each of these elements correctly. Now here's one that would address your problem that you mentioned a few moments ago on all of a sudden finding a defective battery connection. And that is that to begin, you take those little jumper wires I showed, and you check your utility power supply, your battery supply, and your solar supply input. You isolate them from everything else and check the repeater, utility, power, and solar alone. And those are the typical values. Then you connect one at a time. You put the utility power back and connect it so it's running the repeater. Unkeyed the repeater, we show as 13.5 volts. When it's keyed, drops a couple tenths of a volt, which is to be expected. You get 13.27 or so. Then you disconnect utility power, put the battery on. Repeat the same test with the battery, and you see something in the same range of this 13.5, 13.07 volts, perfectly what to be expected. And then finally repeat by solar. So now your solar is running the power of the system. And of course, if it's a shady day and there's cloud out, you may not get that good a performance if you don't have a good solar input. But this gives you, again, also a starting point. So if you come back another time and you have uncertainty in your power connections, you can check back your previous readings. So imagine now you've identified the fact that the repeater is transmitting and receiving, and you want to check the transmit side. So in this case, you take your antenna analyzer and you then connect it on the directly in place of the repeater, and it's feeding directly to your cavity, and then that feeds to your lightning protection and up to the antenna. So at this point, you now should see an SWR that's definitely under 2. On a good system, it probably would be about 1.2, 1.3, something in that range. And that means you are testing all 3 of those components together. And if that value is satisfactory, you can go on to other tests. But if it looks odd, then disconnect the filter cavity and connect your antenna analyzer directly to the cable going to the transient protection. Check it again. You should see exactly the same waveform. Then disconnect on the output side of the transient protection, and then check your antenna. And in all those cases, you should see an SWR under, well under 2. And if anything is out of line, you've now localized the problem, and you take further action on fixing that element. You can do the very same thing in the opposite direction. You disconnect the antenna line from at the receiver input, put your SWR meter, and now you're measuring the antenna backward through the cavity, through lightning protection up to the antenna. And again, you make the tests of the entire sequence in a row, and then eliminate one, eliminate one. And if anyone that is out of line, unusual SWR, you focus on that as your trouble point. This is a technique that I mentioned earlier that is very powerful and very useful. And that is to be able to check your repeater sensitivity using a handy talkie. If you don't have a service monitor, this is the next best thing because it is calibrated. Now the trick is to find one of these decade attenuators. It goes from 0 to 100 dB, and then has an interdial that goes 0 through 9. So you can set any dB attenuation from 0 up to 99 dB. So you can set your HT at its lowest power level, connect it to the receiver, and by adjusting the attenuation, you can get the sensitivity level of the receiver. We'll talk about that a little bit more in a minute. So you set to a high attenuation, reduce the attenuation, wait to break squelch. When you break squelch, then you can estimate your dB transmission level. 5 watts is 37 dB, 1 watt is 30, and a half a watt is 27. And in between those values, you can kind of make a guesstimate about your dB level. Then you look at the attenuation that you put in, and you subtract that value, and you will now find the sensitivity of your receiver, and it should be at least minus 90 dBm. The absolute ultimate is about minus 120. That is typically the lowest possible sensitivity, lowest detection level. But in real life, it's probably be more like around 100, 110, something in that range. So you record this, because when you come back later and you're having trouble, you want to know what the measurement was when you were not having trouble. And then the loss of sensitivity can be due to external functions such as antenna breaks, lightning suppressor, and so on, but it also could be a change in the repeater itself. So you would then go back into those other diagnostic methods that we went through for external antenna testing. Here's a test that I can actually do from home, and that is I take that setup with the HT and the attenuator and put it into a rooftop antenna. And so I then activate the receiver until it breaks squelch. And then in this case, I can measure my power level by feeding it directly into my service monitor. So I don't have to make those rough guesstimate numbers. I can get the precise value. And it's rather amazing, but I can hit the Bark repeater from my home with, as you see in that yellow circle down there, with 7 milliwatts, 6.9 milliwatts. That's 6.9 thousandths of a watt, which is the equivalent to 8.3 dBm. And so if the repeater comes in later on and say instead of 8.3 dB, I've got to go to say 14, 15, 16. With that large and a signal level, I must be having some kind of a problem. So there is our math on that. 8.3 dBm is the power level, 7 milliwatts. Now, what if a distant user loses service? Somebody out in the boondocks lose service and said, you know, I used to have that repeater come here reliably, and I don't hear it anymore. Well, in this case, you connect your RF power into a dummy load, and then use the antenna analyzer to check this output chain. You go to the cavity, lightning suppressor, and your antenna, because you're looking for some loss of power outside the repeater. Into a dummy load, you should see full power level. When you then go into your antenna system, you should, if you have any kind of a disruption, for example, you won't get the proper SWR, you've had some kind of loss inside the antenna. And that's helps you then analyze step by step through that antenna sequence. Now, the repeated kerchunking. This one, I've heard it a time or two. It's very rare. You should not see this ever on a well-installed system, but you could see it due to cable problems. If cables got wet or you had some kind of a connector problem. And what it comes about from is what they call desensitivity. And the kerchunk comes about when a weak user keys his transmitter, the receiver unsquelches, the transmit activates, and then that transmit signal comes back and it neutralizes the squelch, and the receiver re-squelches, silences. Then after a slight delay, which is built into the design of the repeater, the squelch will, the transmit ends, the desense problem ends, then the repeater unsquelches again. So it's like a cat chasing its own tail. You'll hear a repeated unsquelch, unsquelch, unsquelch. On lesson 4, we went into this, and you have to measure the desensitivity with a service monitor. It's a little bit involved, but you connect the service monitor to the input of your receiver, set a low signal level, and then manually activate the transmitter, and you can measure the dB level of shift. And if it's 1 or 2 dB, that probably would be acceptable. In most repeaters, it should be absolutely 0. If it's a properly designed repeater, you should see no shift at all. But if it was anything more than what you could barely measure, like a dB or so, then you want to investigate. And the problems generally are cable shielding. Either the cavity filters aren't doing their job, they're off tuned slightly. It is most likely, though, a shielding cable, crosstalk between cables. And of course, the problem is the transmit signal is getting into the receive side. Now, weather and wind. We just went through some of this recently. Rain can increase background noise. You hear this more in HF than you do in VHF. I'm not quite sure the degree it plays. In VHF, the rain will decrease your receive signal level a little bit. The receiver will not quite have the range that it had before on the receive side. But rain can cause a little, it's a little more than a hissing, kind of a little light buzzing in the background, which is actually effective rain on the RF and on your antenna. Pretty unusual. A little more likely, of which you do not want to have, is if you actually hear signal breaks and clicks. This would be due to wind motion. And in that case, you likely have a loose antenna mount. You maybe have a broken wire somewhere in the antenna conductor, maybe a loose connector. And we've had a little bit of trouble along this line in the past with the bark repeater. So it's been a nuisance. It is less likely on a feed line because the feed lines might flex a little bit, but it's unlikely that they have any noise producing element from the feed line. You're looking at more like mechanical things like connectors and mounts. Here's one that you hear fairly often in nets, and that is that you have a user coming in and their signal is loud and it ends up with some crackling in the sound. It is noticeably louder than other people, and then it crackles or gets a little bit of distortion. The question then is this heard from all users or very few? If you're running a net and everybody has that crackling sound, it's likely a repeater problem. If only one user has it, it's likely that user. So in that case, For a single user, you would quietly offline counsel the user on reducing mic gain, because that transceiver is set with too high a mic gain, overmodulating, and he's over deviating from the required beyond the 5 kilohertz that's a standard. And one way to check that is the word for, F-O-U-R, because when you're doing a HT check and you want a test signal, you say the word for, go for to the other person. And if it sounds clear and clean and at the same level as other people, then you've got your deviation set properly. And for some reason, that word has the best sound level to do modulation tests. And if most users have some sort of a distortion on the signal is too loud, likely then the repeater is overmodulating. So in that case, on our, again, lesson 4, we went on how to set that. You basically put a correctly modulated signal out from the service monitor. You set it to a 3 kilohertz deviation, 1,000 cycles per second, at a fairly low signal level, minus 80 dB. Feed that into your repeater. It should unkey, and then you take the repeater output in RF and feed it back into your service monitor and evaluate the modulation, and there are scales that do this. So you're running the service monitor to what they call full duplex. It is transmitting and receiving at the same time, but it is a standard signal going out, and it also then makes correct, precise measurements coming in. And so you would set your repeater with a 5 kilohertz deviation going into the repeater. You want a 5 kilohertz deviation coming out, and then you are right on the money. This is all covered in lesson 4. Another possibility, we don't have as big a problem around here, but in the southeast areas and South US, lightning is a real problem. And your lightning suppression devices, whatever style they are, some will withstand strikes nearby. They'll withstand transients. They'll cure themselves, but at some point they're sacrificial. They will, if with a big enough lightning disturbance, they will be damaged, and they'll either fail open circuit or short circuit. But they failed. So one step to know ahead of time is, does your suppressor have DC continuity or not? Sometimes you're making a connection test with a ohm meter, and so if the lightning protection device internally has an open circuit, the ohm meter test won't work. So it's good to know which style you are using. And then to check the antenna analyzer, we'll check with an antenna analyzer. Then just put a dummy load on the far side of the lightning suppressor and measure your SWR through it, and it should be 0, because remember, you are going straight through the device and there are no frequency sensitive elements. It should be lossless to the limit of your antenna analyzer. Something like less than a dB, and generally that is below what the antenna analyzer will reveal. So if you don't get if you get anything other than a 0 SWR, replace the lightning suppressor. So the major lessons on this, as I say over and over again, keep your notebook up to date, because when you come to a repeater after some months lag, 2, 3, 4 months later, you make a measurement and you want to know, what was it like the last time I was here? So keep that information fresh. Any club managing a repeater should have or be able to borrow a service monitor. They're available on the used market. Usually they're between 5 and 15 years old, and they sell for roughly $1,000 and up. Under $1,000, generally there's a maintenance problem as parts, something damaged. The ones that are $800, $900 usually have a problem. So from $1,000 to $1,200 up, a lot of the prices average in sort of in the $1,800 area, and $3,000 is the absolute top number, and by that it should be in current calibration. And if you wish to delve more deeply into this technically, and you say, how can I get involved in repeater understanding and maintenance? And it is quite interesting. It's quite rewarding. It's a bit of a challenge to learn everything and to research it, but I get quite a kick out of it. So find a local club and volunteer, because they're always looking for people who are looking to do technical maintenance. So for resource material, the barkradio.org/training, at that page is our directory for resource material, and shortly these 5 lessons and all of the support material will be posted there. And we've also established for club use the K6YUV Slack, at which we're going to have PDFs, questions, and discussions, but that is a closed Slack system just for the club members. And as I mentioned before, on YouTube at K6KN space Bill, these are all posted. And also definitely check repeater-builder.com. This is an archive where about 20 people have contributed kind of a memory dump, everything they know. They've written very complete, very thorough technical papers. There are directories of manufacturers. There are the instruction manuals for a lot of the books. There are histories of equipment, so you can figure out from serial numbers how old your unit is, when it was made. A good resource. And then the ARRL Handbook for Radio Communications is about 900 pages, and it's a must for any radio amateur's library. There's a chapter on repeaters, and the same with the ARRL Antenna Book. There's a chapter on repeaters and on 2-meter antennas. So that wraps us up for this session. This is Bill Ragsdale saying thank you very much, gentlemen. This has been a pleasure, and we'll see you around the repeater world.